Hello friends, in today's video we will discuss about Mohs scale of hardness. So what are the topics we will discuss in this video? Mainly what is hardness, what is Mohs scale of hardness, what is the its historical background, what are the minerals coming under Mohs scale of hardness, how many silicates are there, how many oxides are there, how many hydroxides are there, and what are the advantages of the scale and what are the limitation of the scale. So let's get started. So Mohs scale of hardness, this is the very basic and common topic of graduated geology student. We'll start. Mohs scale of hardness is a qualitative scale that measures the hardness of a mineral by its ability to visibly scratch the softer minerals. So this is not a quantitative scale, this is a qualitative scale. So what is qualitative? Qualitative means this is comparative, means comparison to this material, this mineral is soft or hard. This is qualitative. Quantitative means it will give some absolute number, like this hardness is 1500 or like that. This is a qualitative scale. Suppose we are giving, suppose as already we know the there are 10 minerals, like talc is talc's hardness is 1, and likewise talc, gypsum, calcite. But there, although they are given as hardness 1, given 2, but their absolute hardness varies. So this is the qualitative measure of hardness of minerals by ability of visible scratch of this scratch on softer minerals. This scale is not perfect, but it's a great tool for quick identification of rocks in the field. So uh, this measurement is not perfect, but it helps in quick identification. So here is a look at the scale, how ordinary minerals and objects rank, how to perform most tests. So a German mineralogist, Friedrich Mohs, introduced the Mohs hardness scale in 1822 in his treatise on mineralogy. So he designed the scale as a practical tool for identifying minerals using simple scratch test. So what are the key features? Most scale harness consists of mineral 10 minerals. One is the softest mineral and 10 is the hardest mineral. So based on their scratch resistance. So it is an ordinal scale. Ordinal scale meaning there is steps between numbers are not equal. Means like suppose there is suppose there is corundum and there is diamond, but the corundum hardness is 9 and diamond's hardness is 10. But this is not the in true case, this is not the fact. Corundum's hardness will be in absolute scale will be something more, and there will be like 100 times higher hardness in case of diamond. So this is not the true hardness. So this is a ordinal scale. Diamond is it is written here. I'm taking this marker. So it is taken here. Diamond is 10. Diamond whose hardness is 10 is much harder than corundum, as it is written here. Is not just 1 unit harder. So the test compares an unknown material to objects of hardness. So in this test we use some unknown materials, like we have chosen some mineral and we'll take some known material. Known material means a penny or or fingernail. Fingernail is always available with us. So in fingernail we can scratch this. We got a talc, and we don't have any material to taste whether it is hard or soft. So in fingernail we can scratch it. So we'll get to know whether its hardness is higher or lower from the fingernail. So hardness is not same as toughness. A hard mineral may still break easily. So hardness means it is not a it cannot break. So like quartz, although quartz don't have cleavage, we can break quartz. So the Mohs scale is widely used for field identification education of geology students. So this is the Mohs scale of hardness: talc, gypsum, calcite, fluorite, apatite, orthoclase, quartz, topaz, corundum, and diamond. So quartz hardness is 1, gypsum is 2, calcite is 3, fluorite is 4, apatite is 5, orthoclase is 6, quartz is 7, topaz is 8, corundum is 9, and diamond is 10. So there is also some materials, no materials with known hardness is given, like fingernail whose hardness is 2.5. So if we are getting a mineral, if it is scratch, we can scratch the mineral with a fingernail. So we can get it here that the mineral is less harder than 2.5. So hardness will be lesser than 2.5. So similarly, copper penny's hardness is 3.5. Suppose a like a knife or a glass whose hardness is 5.5. So like that we can check. And a steel nail is 6.75, and a drill bit hardness is 8.5. So if a mineral we are getting and it is we can scratch it, we cannot scratch it by a steel nail, but we can scratch it by a drill bit. So what we can conclude that the hardness will be between 6.5 to 8.5. So this is the how we can test comparative test in case of this Mohs scale of hardness. So next, the Mohs scale ranks minerals on a scale from 1 to 10, in which 1 is the softest mineral, 10 is the hardest mineral, diamond is the hardest mineral with Mohs hardness of 10, talc is the softest mineral. And as I have already told these things, it is ordinal scale, and each step represents a relative ranking rather than fixed increased hardness. So this is a ranking, this is not fixed scale of hardness. So this is a ranking, so we should know this. Like for example, diamond is 4 times harder than corundum, while corundum is twice harder than topaz. So this is fact. Here I have shown the table of Mohs scale of hardness with their absolute hardness as well as a chemical formula. So chemical formula is very important. You cannot remember all the like formula, but the basics like gypsum, calcite, fluorite, and orthoclase, quartz, corundum, diamond, all these minerals you should remember properly. And another important things comes here, like how many silicates are there in more scale of hardness. So how many, as you can see here, talc is one, then orthoclase, then quartz, then topaz. So how many? Four silicates are there. So how many oxides are there? You can see from here, corundum one oxide, and another quartz is also one oxide, SiO2, another oxide. So how many oxides? Two oxides, four silicates, two oxides, and how many hydroxides are there? Hydroxides are there like two hydroxides are there here, like gypsum and talc. So you can say two hydroxides are also there. So you can know this. And this is here absolute hardness is there. Tax absolute hardness is 1, gypsum 2, calcite is 14, and fluorite is 21, apatite is 48, orthoclase is 72, quartz is 100, topaz is 200, and corundum is 400, and diamond is 1500. So this is the absolute hardness. But what we are seeing, we are studying here Mohs scale of hardness. This is a comparative scale of hardness, that is ordinal scale. So here it is given the silicate minerals we have separated out from this table, and also here we have provided their silicate structure. So talc it will have having phyllosilicate structure, orthoclase having tectosilicate, quartz tectosilicate, and topaz nesosilicate. So this also you can remember, this is very important. And then another some important information about the scale, like talc crystal system monoclinic, and cleavage is perfect, not one this is the cleavage, and this is also gypsum monoclinic, and this is their cleavage. And calcite trigonal, fluorite isometric, apatite hexagonal, orthoclase monoclinic, and quartz trigonal. Here some important thing is quartz is not having any cleavage. So topaz orthorhombic, corundum trigonal, and diamond isometric. Corundum is also not having any cleavage. So this here, you can remember the crystal systems, and also two important thing is their cleavage. Quartz is not having any cleavage, and corundum is also not having any cleavage. And other you can remember the cleavage planes. So we'll go next. So how we will interpret the Mohs scale of hardness? A scale doesn't measure how deep a scratch is. We are while giving a scratch, we will not measure how deep is the scratch, but we have to only confirm that the scratch is visible or not. If suppose two minerals are there, A and B, if A scratches B, then A is harder than B, and vice versa. So materials with equal hardness may scratch each other. So to improve accuracy, multiple points and compare against several reference materials. So there are some several materials we can use as are falling on under Mohs scale of hardness, like 0.0.2 to 0.3 cesium and rubidium, 0.5 to 0.6 lithium, sodium, potassium, candle wax, and 1 is talc. Then 1.5 gallium, strontium, indium, tin, barium, thallium, lead, graphite, ice. 2 is calcium, selenium, cadmium, sulfur, terullium, bismuth, gypsum. And 2 to 2.5 fingernail, mica, salt, rock salt, umber. 2.5 to 3 gold, silver, zinc, lanthanum, aluminum, cerium, jet, pearl. And 3 is calcite, copper, calcite, copper, another. Here calcium is there too, but here calcite is there. Calcite, copper, chalk, dentin, thorium, arsenic, antimony. Then 3.5 is platinum, sphalerite, chalcopyrite. In 4, fluorite, nickel, iron. 4.4 to 5 is ordinary steel. 5 is apatite, tooth enamel, obsidian, palladium, zirconium. And like that in 5.5, glass, beryllium, cobalt, hafnium, molybdenum, turquoise, and lapis lazuli, opal. Like 6 is orthoclase, uranium, titanium, germanium. And then niobium, manganese, and 6.6 to 7 is iron pyrite, silicon, ruthenium, opal, peridot, tanzanite, iridium, jade, rhodium, pyrite, garnet, jasper. Like that you can remember. I am not going to read. Here in 10 is diamond and carbonado. Carbonado is a type of diamond, that is black diamond. It is also important to remember, like what is carbonado. Then another 9 is also mogianite. Mogianite is a type of silicon carbide or carbodum. So this is also you can remember, and boron, like boron carbide, you can, these things you should remember. And in 9 it is coming ruby, sapphire, tungsten, aluminum, titanium nitride, like that. So this is harness of some known minerals. This is common minerals we should have in our day to day life. So fingernail is 2.5, copper coin 3 to 3.5, knife blade 5 to 5.5, window glass 5.5, steel file 6.5, and quartz 7. Then how we should start a test as a fresh geology student or some other basic student, basic graduate student. So first, choose a fresh or clean surface of the material or mineral you want to test. Then scratch it, if with a known object, known object with known hardness, what I have told before. So this is known as tool. So if you are scratching with fingernail here is the tool. Then um, then after scratching, you just see with a visible light if it is visible or not. Then if the tool scratches the sample, then sample has lower Mohs hardness than the tool, and vice versa. Suppose if a sample is scratched by a quartz point, then the sample is harder than has less hardness than 7. So this is the test we can say. So we can narrow down, like suppose the sample is not was not scratched by quartz, but it is scratched by drilling bit. So drilling bit hardness is 8.5, and quartz hardness is 7. So the hardness of the mineral will be 7 to 8.5. So we should narrow down whatever means however we can, whatever range we can do, but we should narrow down the range. So then, limitation of Mohs scale of hardness. What are the limitations? Limitations says it is a qualitative scale, not a precise scale. This scale is non-linear, so differences between values varies greatly. Then results depend upon the surface condition and testing technique, like surface condition. Suppose we are taking a mineral, the surface is not smooth, it is rough surface is there, so test will be not strengthening. Then it may damage valuable samples, so this is a destructive method. Like we suppose we are testing a gemstone and we are making a scratch on the surface, so the gemstone value will be less, so it is a destructive method. So it is not a major properties like toughness and strength. So these are the limitations. So what are the alternatives? So more precise hardness measurements use controlled and identification rather than scratching. So scratching, without scratching, there are several methods like Vickers hardness test, Rockwell hardness test, Brinell hardness test, and Knoop's hardness test. Here I have provided one figure that represents the Vickers hardness test. How Vickers hardness test is has been done, and this is also Vickers hardness test is very commonly used in measuring the hardness of specimens in case of engineering geology, to know the physical properties of the rock or mineral. So this is also important. So in next topic we will study about the Vickers harness test.